In example 4, we saw two examples where we looked at a group and a homomorphism, and we looked at the factor group of the group mod the kernel and compared it with the homomorphic image of our group under our homomorphism. And we saw that those two smaller groups were isomorphic to each other. And we, in particular, saw in part B of that example that U16 mod the kernel was isomorphic to theta of U16. We can generalize this idea to say if we have any group and we have a homomorphism phi from G to G bar, then the factor group of G mod the kernel of phi is isomorphic to the homomorphic image of phi of G. And that result is, we're going to write that down, that is a statement of the first isomorphism theorem that we are seeing in theorem 10.3. So let's go to theorem 10.3 right here. So we have phi from G to G bar is a homomorphism. Then the mapping from G mod kernel phi described by G kernel phi goes to, maps to phi of G is an isomorphism. So we just already wrote it down in symbols. This is G mod kernel phi is isomorphic to phi of G. Theorem 10.4 tells us that any normal subgroup of our group G, you can view that as a kernel of some homomorphism. So every normal subgroup of our group G is a kernel of our homomorphism of G, and in particular, a normal subgroup N is a kernel of the mapping that sends G to the coset Gn. So what do these two theorems tell us? So together they tell us, they reveal that there's a correspondence between the factor group groups G mod K and the homomorphic images phi mod G. And we already saw this illustrated in some diagrams. These are called commutative diagrams, and so I'm going to draw it out one more time. So the groups in play are the groups G, phi of G, and our factor group G mod K, where K is the kernel. And then we have our original homomorphism phi going from G to phi of G. And we have this natural map that we're going to call gamma that takes an element in G and maps it to its coset of the kernel. And then we saw that we get this isomorphism from the factor group that we called psi by taking a coset and mapping it to the same thing that A gets mapped to under phi. And this is called a commutative diagram of the situation. And basically what it says is we have this relationship that takes us from G to phi of G, but we could also go the other way around. We can go from G to a factor group first and then move on and have this isomorphism, this relationship, this natural relationship, correspondence from the factor group to our isomorphic image.